All right, welcome to the Unit 6, Lesson 3. It's actually the fourth day of us doing this, but it is Lesson 3. It's the third thing we've learned how to do. We're going to multiply and simplify radicals. The rules for simplifying radicals are that we need to put things in simplest radical form, which means that there are no perfect squares like 4, 9, or 16 in the radicand. Because if there are, I could break those down and pull those outside of the square root. Right? So don't leave any perfect squares inside there. There should be no radicals in the denominator. If I have the square root of 2 on the bottom, that's no good. We'll talk about how to deal with that in the next unit. Also, there should be no fractions or decimals underneath the square root. So for example, I don't want to have the square root of 4 over 9. Okay? I would have to simplify that. And we'll talk about that in the next lesson. So let's investigate. So we're going to investigate what happens when I take, if A is 4 and B is 9, I want to take the square root of A times B versus the square root of A times the square root of B. So if I multiply underneath the radical, I have 4 times 9. Okay, that breaks down into 2 times 2 and also breaks down into 3 times 3. So therefore, because it's a square root, I can take out a group of 2's and a group of 3's. I take out the 2, it goes on the outside as a single 2. Take out the 3's, goes out as a single 3. I get 6. And there's nothing underneath the radical. Let's try to do it with them separate. If I do the square root of A, which was 4, times the square root of B, which is 9, the square root of 4, of course, is 2, the square root of 9 is 3, I got 6. Okay, well that was cool. I don't know if that happens every time, but it looks like the square root of A times B is 6, and the square root of A times the square root of B is 6, when A is 4 and B is 9. Let's try it again to see if it works for the next couple ones. If I have the square root of 25 times 4, now A is 25, B is 4. I break that down, it's 5 times 5 and 2 times 2. Then I get a 5 to come out and a 2 to come out. I have 5 times 2, which is 10. Nothing's enough underneath the radical. How about the square root of 25 times the square root of 4? The square root of 25 is 5. Square root of 4 is 2. I get 10 again. Well, that's twice in a row. This might be onto something here. Let's do the last try. We'll do one more pair just to make sure that it works every single time. Square root of 4 times 36. Square root of 4. Square root of 2 times 2. 6 times 6. I have a group of 2's and a group of 6's. Let's pull them out. 2 times 6. And the square root goes away. There's nothing left inside. I have 12 as my answer. And finding the square root of 4 times square root of 36. Square root of 4 is 2. Square root of 36 is 6. 2 times 6 is 12. Well, it looks like we have a pattern. The square root of A times B is the same thing as the square root of A times the square root of B. So as long as the indices are the same, I can separate these out. So, for example, if I have 5 times the square root of 300, 300 is actually, well, 30 times 10. That works out kind of nice. If I wanted to, I could write this as 5 times the square root of 30 times the square root of 10, because I just proved on the last slide that if I multiply inside the radical, it's the same thing as multiplying with the radical in two different spaces. This is nice because it allows us to separate out the radicals into smaller pieces so I can factor them more easily. Now the square root of 10 is going to have to stay the square root of 10. It's going to be 5 times 2, and that's not going to get us anywhere. But the square root of 6 times 5, well, 6 can be broken down into 3 times 2. Oh boy, that didn't really help us either. Well, it looks like we maybe should have left this alone. Let's try that one more time. Now this isn't always useful to separate. You might want to separate later, but it looks like we had to keep them in the same radical this time for it to be useful. 3 times 10 times 10. And now I have a group of 10's. Let's take that out. Now I have 5 times 10 times the square root of 3. I have 50 times the square root of 3, and that would be my answer. So separating the radicals this time wasn't very helpful. Maybe next time it will be. So if I have 3 times the square root of 125, 125 is 25 times 5. Now I know that 25 is a perfect square root, so if I separate out the radical this time into the square root of 25 multiplied by the square root of 5, well, of course, the square root of 25 is just 5. 3 times 5 is 15 times the square root of 5. Now, these two do not simplify by themselves. 3 times 2, no perfect squares in there. 3 times 5, no perfect squares in there. So that doesn't help us. However, the square root of 6 times the square root of 15 is the same thing as the square root of 6 times 15. And now I'll have enough factors to use that I'll be able to pull out a pair of 3's, because now you see, when they're both under the same radical, I'm able to get a group that I wanted. So these two 3's together will pair up and go outside, make 1 3 on the outside, and I have 2 times 5 on the inside, so it's going to be 3 square roots of 10. Again, we have a prime number of 13 times 1. Nothing's going to happen there. The square root of 52, well, it's going to be 26 times 2. And this is going to be 13 times 2. So we can simplify that by taking a group of 2's out. Square root of 13 times 2 times the square root of 13. Now look, I have the square root of 13 times 2 square roots of 13. Now I'm not adding. This is not going to be, it's not 3 square roots of 13, because I'm not adding. I am multiplying. So when I multiply with the same index, square roots, I can combine underneath the radical. So I have 2 times the square root of 13 times 13. And the 2 did not go inside because 2 was never inside the radical. Only the 13's were. So now I have a group of 2 13's inside. So I get a 13 on the outside and nothing left in the radical. So it's just 13 times 2, 26. If I'm going too fast, you can always feel free to rewind this video. Now when I have a square root of 2 on the outside of a grouped parentheses like this, I'm going to treat it just like I would any other number outside of parentheses, and I will distribute. Now 5 times the square root of 2 is 5 times the square root of 2. I can't make those 2 and that 5 multiply together because the 2 is the radicand underneath a radical symbol, while the 5 is just out on its own. So I cannot put the 5 underneath the radical. However, on this side, I have the square root of 2 times the square root of 8. And both of them have the same index, and they're under a radical. So now it becomes 5 times the square root of 2 minus the square root of 16, or 8 times 2. Let's just show that step to show what I did. And now I have 5 times the square root of 2 minus the square root of 16, which of course is 4. 4 times 4 is 16. So that's going to be my final answer. You might be asking, Mr. Lovelace, why can I not take 5 minus 4 to get 1 square root of 2? Well, they're not like terms. The 4 does not have a radical 2. So I can't do that. Let's look at the next one. Distribute the 2 to both the positive 2 and the square root of 3. So I have 2 times the square root of 2 plus 2 times the square root of 3. Well, the 2 and the 2 can multiply to make 4. And then 2 and the square root of 3 cannot multiply together because it's like the 3 is in jail. Right? I cannot go in there. I'm not in jail. I'm just on the outside, just visiting. Now, on the third example, I must distribute the square root of 3. So I have 5 times the square root of 2 times the square root of 3. It came from the outside. If you want to think about it, that square root of 3 just came from the outside. 5 square roots of 2 were on the inside here and multiplied by the square root of 3. Then I have a minus sign, and the 2 square root of 6 were already in there. But then I have to multiply by another square root of 3 that came from the outside, like this. And so the things underneath the radical with the same index are like terms, so I can multiply them together. I have 5 square roots of 6, that's 2 times 3, becomes the square root of 2 times 3, minus, it's going to be 2 times the square root of, looks like 18, because I combine the 6 times the 3, make 18. Now I need to simplify this. So I have 5 square roots of 6 minus 2 times the square root of 9 times 2. 5 times the square root of 6 minus 2 times 3 times 3 times 2. Group the 2's out. 5 square roots of 6 minus 2 times the 3 that I pulled out, the outside. Now I have 5 square roots of 6 minus 6 square roots of 2. Done. Final example on this slide. You have this entire thing, 3 square roots of 2 multiplied by the entire inside. So I have 3 times the square root of 2 multiplied by that square root of 24 that was already inside there. Plus, and then I had this 3 times the square root of 2 times 2 times the square root of 6. I'm going to run out of room there. I'm going to try it again. So times 2 times the square root of 6. Now I multiply everything with radicals in the same index together, so I have 3 times the square root of 2 times 24 plus 3 times 2 times the square root of 2 times 6. The 2 and the 3 multiplied together, and the 2 and the 6 multiplied together because they were like terms. If I break this down further now, I have 2 times 12, right? I could break that down even more. I'm just going to focus on the left side for now. 4 times 3, 3 times, and then again 2 times 2 times 2 times 2 times 3, plus, and this one's going to be 6 times 2 times 2 times 3. And I can pull out a group of 2 of the 2's here, the outside, and I have 6 times 2 square roots of 3. So it's going to be plus 12 square roots of 3. Now on the left side of the plus sign, I have 2 groups of 2 here, so I'm going to take out a 2 for that, 2 for that. It's going to go away. 2 times 2 times 3. 4 times 3 is 12 square roots of 3 plus 12 square roots of 3. And then I get 24 square roots of 3 because I have the same radicand, the same index. That's all for this video. If you need to rewatch it, I highly encourage you to do so. I hope you have a great evening.